Let's now consider the third and final type of molarity problem, concentration dilution problems. Dilution, of course, happens when you just add solvent to a solution, and a concentration is when you take solvent away. And herein lies the key. To identify a concentration dilution problem, you are only changing the amount of solvent. You are not changing the amount of solute. There's a very simple mathematical relationship that describes the relationship of the solution before a concentration or dilution occurs, and that same system after the concentration or dilution has occurred. That relationship is CV equals CV. The concentration times volume before is equal to the concentration times the volume after the dilution or concentration. Here I show primes to denote after. As a quick aside, most chemistry books, or a lot of them, will teach the formula MV equal MV, and that's because concentration is normally provided in molar units, and the volume is left somewhat generic with just a V because either liters or milliliters will work. I actually prefer CV equals CV because in the real world, my volume may be, say, gallons, and my concentration may be, say, weight percent. So this is a much more robust and versatile formula. Well, let's look at an example. You have 176 milliliters of a 0.5 molar solution of calcium chloride. But you leave the top off the container. Days later, you find that 55 milliliters of the water has evaporated. So you now have a new system. Since water has evaporated and water is the solvent, you know now you have a concentration problem. Since you have a concentration problem, you know that the formula CV equals CV is going to work for you. This is all the calcium chloride you have, so you must use this sample, but you can only use it if you have the new concentration. So what is the new concentration? Let's substitute in the numbers. Before, you had 0.5 molar concentration and 176 milliliters. And after, we're trying to calculate the concentration, but now we need to know the final volume. Let's see, what was the final volume? Was it 55? No. That was the amount of material lost. The new volume is 176 minus 55. The material we started with minus the material we lost gives us the final volume. So let's substitute those numbers into our equation. Rearrange the equation and solve it. And so the final answer is 0.727 molar. What that means is you now can put a label on this container and use it for other calculations or other things because it's no longer an unknown. Let's do one more. A lab tech wants to dilute 50 milliliters of a 0.35 molar sulfuric acid solution to 2 molar. To what volume must the original solution be diluted? Well, that's easy enough. We can see that we have a concentration and a volume before, and we have a concentration, and we need to know the volume at the end. So we merely substitute in C times V equals C times V. Okay, here I use A's and B's for before and after as opposed to unprimed and primed, it's the same difference. So before we had 3.5 molar and 5 milliliters. After, we now have 2 molar, and I don't know the volume. And once I do the calculation, I wind up with 87.5 milliliters. That's my new volume. Now here's the tricky part. What volume of water must be added? So here's a tripwire. When you get volume with these, that's the total volume. This is the total starting volume. This is the total ending volume. Sometimes you need to know the total volume, and others how much is added. So in this case, how much was added? Not 87.5, that's our final volume. How much we added was the difference between that and what we started with was 50 milliliters. In other words, your total volume is equal to what you started with plus how much you added. So we're trying to calculate this, but we know our total. We just calculated that, and we know the initial. Substituting those two in, you get 37.5 milliliters. So what that means is that original solution, there was 37.5 milliliters added to it, and that brought the total up to 87.5 milliliters and a new concentration of 2 molar. And that's all there is to concentration dilution problems. Now, for those of you who've watched to the end of this video, I have a special insight for you with respect to exam 3, a little bit of a summary. If you look back at all the material that we've studied so far, there's been 3 general classes of questions. We had stoichiometry type of questions, we had composition type of questions, and we had molarity type of questions. Each of those general classes had, by coincidence, 3 types of questions. So the types of stoichiometry questions are those grid type of calculations. Then a variation of that was percent yield. And then another variation was limiting reagent. How about chemical composition? We call this a type 1, where we went from molecular formula to weight percent. The second type was where we went from weight percent to empirical formula. And the third type was where we went from empirical formula to molecular formula. And finally, molarity, we've discussed the 3 types of molarity problems. Calculate molarity when you're given grams or moles of something. Use molarity to calculate something else, using it as a conversion factor. And then finally, what we just covered was the concentration and dilution. And with that, you have all of the information that you need to be successful on exam 3.